Hello everyone, and welcome to our first Northern Australian climate webinar. We have been extending climate in eastern states since 2013, and this is the first time we've engaged these northern growing areas and had a good look at the science, and again reported on that with this new climate e-news that's going out every month. This is very much a 101 today. We are going to try and compress it to 30 minutes. And the content will contain just a review of findings, very much a summary, nothing too scientific and too detailed. Then I'm going to jump out of the slides and just go into the latest Northern Australian Moisture Manager just to show you the value points in there and those information sources. And then we'll move on to just a quick look at the growing season ahead. I understand the current wet season, the monsoon, is historically very late, which has made some media around some parts of the Northern Territory and the Queensland and Western Australian media. So that's probably not great for a lot of people waiting for those rains. There is a definition of how that monsoon arrival is determined. Yeah, so we've certainly got a little bit going on in terms of Mad and Julian oscillation and some rain events coming up that we'll have a look at in a bit more detail. So whilst there are many areas that cotton is grown north of the traditional area around Central Highlands in Queensland was normally the northernmost valley growing cotton routinely, we have identified 4 particular locations, and that was mainly due to the limitation around data sets. The Bureau has some data in, at some airports in other locations, but we just thought in consultation with the industry, with CSD and others, that we would just stick to those 4 locations and try and pick up any nuances with those. Obviously, you've got Kununurra there, which is very, very close to the sea, and Catherine's a little bit more inland. And then you've got 2 more arid locations in Tennant Creek and Julia Creek. And the colours on the key there, you just see are defined by the Köppen classification, which is also in the document, which is defined by rainfall, I guess, and temperature as to how strong those rainfall patterns are, as to how they're classified. Just on top of that, I do have those 4 locations marked on this map provided by Bayer. These are potential locations where cotton can be grown, and CSIRO in their Northern Cotton reports also have identified a whole bunch of areas where cotton can be grown potentially. And I've just got them marked with the ones that we've focused on in the green highlighter there, but certainly there's no reason why in some point in the future that we can't do more analysis. So, for example, the climate at Ayr, I know that's a heavy sugarcane growing area. If the economics and the growing conditions are right in those valleys, we can certainly focus more on reporting in our e-news or even refresh the research document that we've done. But yeah, so I guess it's important, and we acknowledge as me as lead author on that research, that rainfall and solar irradiance, which is the 2 most limiting factors or the 2 most critical factors in growing a crop outside of nutrition, can change a lot in a given location. And you see that in the long-term solar irradiance and rainfall distribution maps, where you have very tight lines where the patterns are quite set on generally how far inland they come. And there's been some really neat research papers written on where those actually defined lines are with climate and rainfall. Just starting off now with the wet season solar irradiance, again, I've marked roughly where those 4 locations are, whilst they're not exactly listed, apart from Catherine and Tennant Creek. What this map shows is the solar exposure from October to April. And you see there that the orange, the darker colour there, is certainly has increased kilowatt hours per metre squared, or megajoules per metre, which is how energy is measured. And the further north you get in that wet season, it does look closely correlated with cloud cover, and it is, believe it will, logically related to rainfall as well. So those northern areas can be limited, but more so by solar irradiance than moisture. And it's the reverse for Tennant Creek and Julia Creek, which are more limited by precipitation. They are solar resource. So that's just a basic intro into irradiance, and we shouldn't forget that that's obviously critical to growing a high yielding crop. I've just got a summary here. It's quite a busy table on just comparing those 4 regions. So I've got wet season rainfall, which is November through to March, those 5 months. And you'll see there Kununurra at the very western end of that study location group of 4 there, roughly 4/8 of 32, so 32 inches of rain for the wet season there, which is phenomenal. And we're looking at 40 inches of rain at Katherine, which is, us in the eastern states can it's hard to comprehend. Moving across to Tennant Creek and Julia Creek, they're much more aligned with these central eastern areas where we're growing cotton around the eastern valleys. More about 15, 16 inches of rain per growing season. And I've just got there the peak month. So the peak month of that is January consistently throughout those locations, and you've got a 250 mils or 10-inch in the old scale at Katherine, which is phenomenal. I'm not sure the cotton would particularly enjoy that. And then what I found interesting here was the difference in irradiance. I thought the difference would be a lot greater than, probably 10% between 33 and 35.5 between those locations. But it seems like a lot more. I guess that 10% can be very critical at certain times. But and the peak month for irradiance is November in those more western locations, and the peak month is actually December. So I guess that's reflective of the monsoon and how it moves from west to east. Traditionally, the rainfall and the cloud cover tends to move from left to right. So that's just a snapshot, just to paint the picture a little bit more for those that aren't so familiar with the climate. Now, we've just generated an interesting chart here using 30 years of data from each of those 4 sites, depicted by different colours. We've got Julia Creek in the very light blue there, the easternmost location, Tennant Creek in the yellow bars, Katherine in the red, and Kununurra in the light green. What this basic coefficient of variation equation or simple output is, that's used in statistics, it's in share markets and all sorts of currency and all sorts of other, traders or analysts use this coefficient of variation, which is the standard deviation of a data set divided by the mean. So what we've done is had a look at each month of rainfall over 30 years, run this basic test in Excel, and come up with a whole bunch of bars where we put the axis at 1. The reason we put the axis at 1 is because from a statistical point of view, if we've got a value that exceeds 1, that's largely kind of described as something that's unreliable. So what we're actually measuring here is the degree of scatter, and you'll see there on the right of your screen the arrows hitting a target. So if you just for a moment recall or have a look at the mean, let's assume that the mean is the bullseye, and you've got a site like Tennant Creek on your right hand of the screen there with a coefficient of variation of 1.3. Now those arrows would look a little bit more like the diagram, the figure here on the right of your screen. So whereas somewhere like we've got Katherine, and nearly all of those red bars are low except for January. So what that means is that the degree of scatter around a mean for those rainfall months. So say for example, we know that December the average value there for rainfall at Katherine is probably around 180 mils for that month of December. So what that shows is over 30 years we've got quite a dense bunch of observations around that mean. When we get back to 1, that shows a little bit less reliability, but 1 is just a general threshold, I guess. And looking across the 4 sites, there certainly are some trends there, where January looks to be, one of those months where it can be more hit and miss. November and December, February and March at those locations, particularly Kununurra and Katherine, look very, very reliable. Yeah, so I just thought that was an interesting measure for reliability when planning a crop forward or looking at fertiliser use or managing your logistics. All right, so into a bit of hardcore science now. Looking at drivers of rainfall and climate, I guess the focus in the document was more on rainfall rather than solar radiance or temperature as such, given the importance of rainfall to have a strong and a healthy crop that's going to be high yielding. There's lots of acronyms in climate and weather for those that their literacy is something that's work in progress. So the measurement of ocean temperatures, and we've got 2 there in text on the left and right, the Indian Ocean, which is measured by the Indian Ocean Dipole, and the Pacific Ocean, which is El Nino Southern Oscillation, quite often referred to as ENSO. We've got the measuring zones of those two broad indicators there that you'll often hear in the commentary. We've got is essentially the tracking of that moisture, whether it's on the left or right, or the Australian side, or in the case of ENSO, or the American side. Or with the Indian Ocean, that's a driver that tends to operate more in the winter and spring of our seasons, whereas the ENSO tends to operate more winter, spring and summer, and resets in autumn. But the main drivers that we're looking at here is, all right, well, how much warm water do we have north of the Australian continent to act as convective moisture for rainfall? So that's a really good place to start, is to track what are these broad indicators doing as a measure of how much moisture is likely to be in the atmosphere. Then we've got this different, unique flavour of ENSO called the Madoki. Now, that's a Japanese phrase that means similar but different. And I guess we've got the theoretical definition of that just on the top screen there. So a traditional La Nina has one giant big circulation pattern that shifts convective moisture in the atmosphere basically from west to east, and you can see there by that little figure blowing that moisture from right to left. When we've got a Madoki situation, we've got the sea surface temperature distributions flanked by warm water at either end, off Peru and in the Australian tropics to the north of us, and you've got the circulation pattern splits up. Now, it took the scientists a long time to work this out. I think it was research that came to the fore around 2005 that the Japanese researchers discovered that, you know, you could actually have a La Nina type situation without being in the La Nina, which is where it came from. And I've just cut and pasted an ocean temperature map there on the bottom, and you'll see there that the Madoki situation is actually what we're going through at the moment. That's set to peak in another month or so, that event. So you've got moisture sort of split up in two separate circulation patterns, where the centre is blowing towards the Peru on one side and towards New Guinea on the other. So that's probably the most topical driver we're looking at scientifically at the moment. And I just wanted to share this with you because this is a chart generated by CSIRO in some journal research done on looking at the impacts of this Madoki phenomenon that's probably unfamiliar to most of you, but we certainly watch it in cotton areas, and we have been for years down here. So when we get a Madoki La Nina like we're in at the moment, the March, April, May correlation coefficients is shown there by those dark colours where it's the strongest. So what we can expect is when we're in a La Nina Madoki like at the moment, we're just about to head into or to peak. Historically, over those 6 or 7 of events that have happened in the last 30 or 40 years, those distributions have been the average of all those different events that have occurred. So I've just quoted the paper there as well. So that's relevant because that's what's actually going on at the moment. So in January 2025, we're anticipating that we'll go into this La Nina Madoki, and that'll peak in February or March this year. So that's very topical, and the map certainly that's of importance at the moment, which could explain why the wet season onset is late. Just jumping now to one other very critical atmospheric driver. We don't have time to go through them all, and for those of you that want to know, we can certainly go through that in more detail one-on-one once you've explored the document. So the Madden-Julian oscillation, two scientists, Madden and Julian, discovered that there was a pulse of moist air, much like the diagram in front of you there, that rotated around the equator every 30 to 60 days. CottonInfo actually made a little YouTube on that and how it impacts cotton areas. And what you'll see there is they gave each geographical area a phase. So phase 1 is on the African side, and then it moves through 2, 3, 4, 5, 6, 7, 8, and then generally tends to reset every 30 to 40 days, or sometimes 60. It's a little bit unpredictable, but the scientists have worked out through various measurements in the layers of the atmosphere and the ocean whereabouts that MJO is. So it's a big invisible mass of convective air that we certainly hope can instigate and propagate some moisture when it reaches the Australian region. But one of the issues they do have is actually when it comes to the maritime continent, which is all those little islands to the north of Australia, it tends to break up when it goes across all the different topography there, and makes it really, really tricky to track and makes it a little bit unpredictable. It's much easier when it's across the oceans, but when it comes to land, it becomes, a little bit harder to measure. But nonetheless, I think out of all the drivers that the 5 or 6 that we've concentrated on in the document, the Madden-Julian oscillation is really one, if you're not across it, just to click on that 3-minute YouTube as to why that's important, because in a situation where it goes into phases 1 and 2, it tends to pull all the moisture back away from Australia, and we tend to get heat waves. And that's actually what's happening right now, where you see on the heat wave warnings, much of the Australian continent is going to receive above average temperatures in many locations. And that could be attributed to the Madden-Julian oscillation just pulling that moisture away, a little bit like a wave when you're standing on the ocean shores, how before the wave breaks, it sucks all the water back in towards the wave, which is one certainly to be aware of. Another atmospheric driver that has a really strong correlation and is certainly related to that Madden-Julian oscillation, and that's the AUSME, which is the Australian Monsoon Index. This has got really strong correlations with moisture, and you can see there the measuring zone. And that's on your right-hand side. You'll see a little schematic there of how that moisture, rising air and sinking air, develops cloud. And that's essentially what the scientists measure. What would be really good, and we don't have it unfortunately, not without subscription, it might be something the industry looks at, is to get a really good data set where we can present that Australian Monsoon Index with a prediction going forward. But having said that, tracking the MJO is a pretty good proxy for what is going to happen in that blue box there in front of you. But yeah, when we have strong convection in that area, we tend to get good monsoonal activity through cotton growing areas. So that's all we're going to spend on the review, and sorry, we're 20 minutes in already, but the full scientific report is on the link, and we can share it with you if you don't have it, but it's embedded in the CottonInfo webpage, and more than happy to go through one-on-one with anyone that wants to go to depth on the findings in that report. So I'll just jump out of this into the latest Northern Australian Moisture Manager. So just a climate summary. This Moisture Manager is meant to be something that's not too heavy going, but has enough information in it. And we do have links also if you wanted to click through in that Moisture Manager. Hopefully all of you are subscribed to that. So we just got a summary at the front end. We have a chart there of weekly rainfall, a summary of climate indicators with some speedo dials. So that's just a broad overview of what's going on with sea surface temps and air pressure. And 2 of those air pressure anomalies, we don't have a good data set for the AUSME, the monsoon index yet. That's something I'm working on. This is the current one. So we've got the Niño 3.4 in wet phase. We've got the Modoki just in neutral phase moving to wet phase. That should be wet there. Apologies for that. And we've got this other one called the Ningaloo Niño, which is a measurement that the Japanese scientists track, which is how warm are those waters off the Ningaloo Reef in West Australia. That's positively correlated with moisture and a good wet season. That's actually very warm at the moment, which hopefully will help that Modoki express itself when it goes into La Niña phase. And then we've got just the SOI, which is probably not so relevant, but more so that the Madden-Julian oscillation is very relevant. And then we've got the Madden-Julian oscillation here. The spider diagram here is probably going to take me too long to explain, but what it shows here is the grey line is the observations, and then the black line is the prediction of that Madden-Julian oscillation. The Australian region is phases 4, 5 and 6, as per the schematic I showed you earlier. So it's predicted to come through here on about the 25th of January, sort of through to the 3rd or 4th, bearing in mind that diagram is a few days old now. And then there's just a really good chart there of 8-day rainfall. And for those of you that aren't on windy, it just gives you the ability to toggle through rainfall accumulation with 3 or 4 of the best global models there on your right-hand screen. I've got them circled. Then just a summary of all these different research agencies. I've just done a cross-section. There's about 8 or 9 global models that are available, but I've just done a cross-section of 6 of those, including the Bureau, UK Met, etc. Just with a summary of what's going on and which tercile you'll fit into. So by terciles, I mean that location will either fit into neutral, wetter, or drier distribution of rainfall for that precipitation period, which is 3 months. Tropical hazards, I'll just show you that in the slides as well. There's a refresh chart which I'll show with you. Heat wave guidance, that's interesting for irrigators especially. To click onto that, you can access that model. Then a really interesting machine learning rain model as well, which you can, again, click onto that chart, and that will take you to that model run, which updates every 12 hours, which is really useful during cyclone events to see where that rain depression or that cyclone is going to end up. So I'll just go back to the slides. The remaining seasonal outlook, you can see there just from the European chart, the Bureau's latest prediction and the IRI in America, the growing season for the next 3 months looks favourable. I guess from my side, and after doing this for a few years now, having that research show that Madoki, if it does peak, and seeing those correlation coefficients, it can deliver significant moisture over that autumn period. But look, nonetheless, the dynamical models are showing confidence that, in some cases, twice the statistical probabilities of receiving wet tertiles in those 3 months, the February, March, April period. Temperature outlook, we've certainly got a cold anomaly there for Kununurra, or very close to. You'd have to think that Kununurra there would be close to that. And we've got a similar blue blob in sort of northern Western Australia as well. And Julia Creek is showing a cooler trend as well, really instigated from probably more cloud cover and less irradiance and temperature. Now, I've just updated this map's fresh out on Wednesdays, and that shows a really active period. And basically you can see here from this tropical hazards map that's updated on Wednesdays from the Americans, you can nearly track that activity, that tropical monsoonal activity. We've got the red shading here is tropical cyclone formation probability. So it looks like it's going to be active right through to the 11th of Feb. So certainly brace yourselves for some activity, and the monsoon looks like it really could be here with a bang during that period, which is obviously very late. Where's the MJO? And I've just refreshed that as well. I've just got here phase 2 tends to be a hot phase for Australia, and then our phases where we get rainfall is, traditionally phases 4 to 6, and that hopefully looks like it's going to play out as per the research. The MJO Explainer, that's a really good one to click on. That's in our video section of CottonInfo, and that's where we've broken down just the actual concepts of the MJO and how to read that spider diagram. And that's it from me. It's certainly happy to take questions, and sorry we just had to rush through. I probably got a bit excited putting the content together and overcommitted a little bit.
That's great. Thanks so much, John. It's an incredible amount of content to race through in 28 minutes, so we're incredibly thankful. I can see that Joe is typing a comment. He said, if the MJO is 40 days, then should we expect 60 days in the following cycle? Is it predictable?
Look, on long lead times, Joe, not really. There's, I think, 8 or 9 research agencies. Each they've got their own interpretation of where the MJO is going to be. So I think, looking at probably 7 to 14 days, I think that the spider diagram is quite useful. And again, the presence of the MJO tends to vary from the start of the season to the end of the season. We found in more southern and eastern locations that early on in the wet season, the MJO rain events tend to be closely aligned with the MJO, and then as the season progresses, the rainfall events tend to undergo some sort of a daily lag, where it'd be 5 to 7 days later, then we'll get something. And similarly with cyclones, you'll see quite often a cyclone will form after the MJO has passed. But look, there's a couple of really good links where you can access every international prediction. So there's good information on where the MJO is, and it's really good at the moment to be doing this presentation and to have a really clear anti-clockwise path of the MJO where we can see where it is and what phase it's going to. But yeah, on long lead times, it's probably not great. But interestingly, in that data set where the reliability for January was quite low in those northern locations, it does sort of comprehend that, you have an MJO event around Christmas, and sometimes it can miss January and then come back in February where rainfall is much more reliable. So yeah, hopefully that answered your question, hasn't gone off on a tangent for you.
Talking reliability, Stephen's put a question in the chat saying, in rainfall reliability chart, data of some sites are missing in certain months. What's the reason for that, John?
No, there shouldn't be any data missing. I guess the gap in the January month, if I just if I duck back to the slide, I guess the way to interpret that, Stephen, is the values are hidden in the one axis. So here we've got we've got a yellow, we've got a blue, and we've got no green bar. So I'm guessing that value is hidden in that. So the actual value there is 1, and we don't have a green bar showing, which was a good pickup. So yeah, that's why we can't see it, because the actual value there is 1 for Kununurra. But all the others should have values. The reason why we undertook the 4 locations, because we did have good monthly data sets on precipitation. Hopefully that answers your question.
Thanks, Jon. Nothing else coming through in the chat at the moment. Stephen said thank you, as has Joe. So thank you all for jumping on this afternoon. If you're not subscribed to the Northern Australian Moisture Manager that Jon has referred to today, please jump on to the CottonInfo website and head to subscribe to do so. And if you've changed your details lately, please update them there. Jon, any final comments from you?
No, I just think for those of you that are embarking on the climate literacy front, feel free to give me a call. We've been doing this for a number of years in the eastern states, and I just encourage people to stay with it. It gets easier. We're hoping to visit the north. I've actually never been up there. I've been to Julia Creek, but no other of those 3 locations. So hopefully the industry can have some presence up there. For those, I think, this is one of the major battlegrounds of understanding the science to manage risk and match your inputs accordingly. So feel free to look me up and arrange a call if that suits. Anything I can do to help.
That's wonderful. Thanks so much for your time, Jon. We really appreciate it. And thank you all of you for jumping on this afternoon. And we'll talk to you again soon. Thank you.
Thanks, Megan.